Good.
We have a full 25 minutes, so we're starting a little bit late, so we're going to jump right into it.
Hey, so welcome. My name is Chris.
Hi, Chris.
And my name is Jeff. Hi, everyone.
And we're software engineers at Warby Parker, and our office is in New York City, right in Soho. So we're going to talk today about Docker a little bit, give a quick intro, and then we'll talk about containers in the cloud. So a quick introduction for those of you who aren't familiar with Docker. It's a software suite that allows you to build, manage, and deploy software applications inside containers. It's also a container engine that runs on Linux and hopefully soon Windows. And lastly, it's a specification for building out new containers, which is going to be the Dockerfile that we'll talk about in a little bit. And what's also pretty cool is it only went 1.0 just about like last year. So it's a relatively new piece of software, but it's gained a lot of traction. But most importantly, so hot right now.
So hot right now. So hot right now.
It's all over Hacker News. People are developing software on top of it, which is really cool. And we like to tease that, but it's actually really great. Popularity is not a bad thing. It gets a lot of eyes on the product, and people build new software to enhance the experience. So real quick, we'll jump right into like what a Dockerfile is. It's a build manifest to actually like build out your containers. What's really cool is they're written in plain text, and they kind of read like a series of bash scripts. So this is an example of all of the commands that like would be inside of a Dockerfile. So we'll see in a minute what these are going to be doing in our specific application. But you can see that the env command sets an environment variable. The add will add arbitrary files to the container. You can think URLs or tar files. Copy will copy folders from your local computer into the container. The work dir is what's going to set the present working directory. And what's cool about this is it actually keeps that, and that persists for the rest of the Dockerfile. We'll see what that means in just a minute. Expose will actually open a container's network port to the network that the host is running on. Volume will actually mount a folder from your local computer directly into the container. So this is cool because changes that you make inside the container will persist outside of the container. And lastly, user will actually set the user inside the container when you're executing commands. It's root by default, but you can change that. So this, we can see, is actually an example of the Dockerfile that we're going to be demoing today. You can see that from the top we have from, and we were starting from a Ubuntu container, which is a very lightweight Ubuntu container based on Linux. And then after that, you can see we're just running a bunch of commands. So we're setting some environment variables on line 4 there. We're actually apt-get updating and installing all the packages that we'll need. And then if you look about halfway down, you can see that we're exposing port 5000. The application that we're going to be demoing is a Flask application running on port 5000. That we're going to be, Flask fans out here, and we'll be hitting that over HTTP. And then last, the Flask app is going to be storing the data in Postgres. So we're actually going to assume the Postgres user executes some commands to get the database bootstrapped, and then we're going to switch back to root. And the last thing is the cmd command, which is what the container will run for the entirety of its lifetime.
So really quickly, I'm going to run a real demo of what we kind of just saw there. So you'll see that this Docker file is this file that we just saw on the slide. And I'm going to run a docker build-t for tag. I'm going to call it work from home ninja. And I'm going to say dot. And so what this actual thing is building is a container for an application that was actually really popular on Hacker News a couple weeks ago called Work from Home Ninja. And that particular application gave you some excuses for why you should work from home. And that's that Flask app running Postgres. I think my network might be a little wacky with there, but luckily, we can actually, so my network for GitHub might have been a little wacky, but I can run a build because I have an image already on here. I can see that here. And so I can run a Docker run of the container that I wanted to run. And I'm going to do it on port 5000, which we talked about before. And what this is going to do is expose it to the actual host container that's going to run it from. I'm going to say a name for work from home ninja. And I'm going to tell it to run as a daemon with the container jefu/work from home ninja. And what that's going to do is going to say that it's running. So there it is. And if I'm lucky, I should be able to run it. So this is straight from the Dockerfile, the container that got created for it, running the entire application without any other configuration for it. If you didn't have a chance to see this on Hacker News, people can just submit things like Gotham Hangover as a reason to work from home. There's an admin panel. I can approve it and go back to the app, and then we can just upload it a whole bunch of times. So that's the basic container, and that's the actual container that we're going to be running with for actually the rest of the talk.
So these containers are great, right? But how do we share them? So Docker actually provides something called the Docker Hub, which is a container repository that they run. You can have an unlimited amount of public repositories, and you can have a certain amount of private repositories if you choose to pay. So it's kind of like the GitHub for containers. So it's actually really simple. The way you push it is actually just pushing your tag up to Docker. And you're asked to log in with a username and password, which you can create for free on their account. And then your repository is there for everyone to share. So if anyone has Docker running on their local computer right now, you can actually pull this repository and spin up our application live. This is actually what the dashboard looks like. So you can see there was 15 pulls because we demoed this a lot when we were practicing. And Jeff has one public repository now, but he can create as many as he wants. So today we're going to go over really quickly 3 different cloud providers. You're probably very familiar with all 3. We have Google Cloud Platform, we have Microsoft Azure, and we have AWS. So to start, Jeff's going to take us through how we did it in AWS.
So just a little context. We're going to run through these really, really quickly. We could probably spend an entire talk if we wanted to get into the depths of each one of these services. But in order to speed things up a little bit, we have I made a little screen share movie to kind of go through each one of these services. So this is AWS, and we're going to go into its container service. And the first thing we're going to do is we're going to create a cluster for AWS. And the container service is where we're going to make many services that are going to run. So the service is created, or the cluster is created, and then we need to create a service within it. And a service could be something like a web app, a actual database, or something else. In this case, we're just going to have one task, and that's going to be the container that we just created. And we're going to call it the Work From Home Ninja PyGotham. And this is where the magic happens right here for this given task. I'm going to give this container name the fact that it's Work From Home Ninja PyGotham. And for the image, you'll see that I'm using the exact from the Docker Hub, the name JeffU/Work From Home Ninja. I'm going to set some of the computer settings for memory and stuff, and I'm going to expose port 5000 like I did for the local container, and I'm going to save it. So for that task definition, you'll also see that I have some JSON here, and this is actually the same configuration that we can use for AWS's command line tools or Bodo in Python. After I have my task definition set up, I'm going to go back to my cluster, and I'm going to create a service that's going to be based off of that task definition that I just set up for this given application. I'm going to call it Work From Home Ninja. And I'm just going to say that I want to have one task. Now, this is an opportunity where I can have many containers running at the same time. For the purpose of this demo, we're just going to put the one. And for our given cluster, that's we're all done. We're all set. Now we just need to get some machine to run it on. So this is where all of your AWS stuff is actually going to come into play. For this example, I'm going to make an EC2 instance, which is a virtual machine in AWS. I'm going to select an AMI, which is base VM image that the entire thing is going to run off. Amazon makes some base Elastic Container Service AMIs available to us. And you can get them pretty easily by searching for just ECS-optimized. Once we have it, we can select that given one. We select the machine that we actually want to run it on. And then there's just a couple of quick settings we have to make that connects that to the container service. One is the role that lets it talk to it. And then this one little thing that's a little bit confusing for people who aren't familiar with AWS is we actually need to have this little script run in this user data thing that's going to indicate that this ECS cluster is the Work From Home Ninja PyGotham cluster. And that's going to register this instance with the containers cluster that we just set up. So after we made those settings, the other thing we need to do is we're going to edit our security group. And this is going to actually open up 5000 from the AWS account into the internet. And once we do that, we can just take a look, make sure everything's looking good, hit launch. And the instance should be running. So I'm going to switch to here. And so at the end of that movie, this is actually what things should be looking like now. And so with that given container that's now running, we should actually be able to have I think that my internet's wacky, but for that given container, it will actually have that application running here in port 5000. So this is live to AWS from that exact container. I didn't have to do any other configuration. It spun up the container exactly the way we created it and has it set up all exactly the same way that we had it running locally. So for AWS, what are some of the great things that we found about it in terms of running that container on it? We thought that it's really great for people who are already on AWS because you get to leverage all the existing stuff that you might already have if you're just running base VMs. There's a lot of stuff that's out there for it. There's stuff like RDSs, the ELBs, which you can do outside of your containers, and you can leverage that really easily, like have a bunch of app containers that connect to the RDS database and abstracts away not having to even worry about your database. And we use just one instance in our cluster, but you could actually also connect this with AWS's auto-scaling groups, which allows you to have AWS manage the number of servers that your containers are going to run on, and based off of your task definition, create much more containers that can manage whatever the spikes are, but also bring it down lower if they're all idle. One of the cons of all the AWS, though, is that there's probably a pretty big learning curve if you're kind of like jumping right into it. You have to speak AWS in order to connect these dots on what AWS does, or it can be a little confusing. So for next, we're going to jump into Google. And this is going to be another quick thing here where we have, this is Google's developer console. I'm going to create a project that's going to be where we're going to be creating all of our things for this container service for it. And I'm just going to name it PyGotham. And for this project ID, this is what I'm going to actually configure on the CLI. So while it creates that project, it'll take a second. And it's within the project that I'm going to go to Google's container engine and see some of the things that we have there. So let's take a quick look in the container engine. And once I click on this cluster thing, it's going to take a little bit time to initialize. But while it's initializing, we're going to take a quick look at like some of the things that you can do in container engine. Unlike AWS, a lot of the commands that you're going to do with our given cluster actually can't be managed through the console. You have to go to the CLI. So while it's initializing, we're going to set a couple things up in our CLI. The first thing is we're going to set the project ID, which is what we just created. We're going to take a look back here, see if it's initialized yet. Still not initialized for our container engine, but while it's going, we can actually set up a command that we're going to run to create the cluster. And similar to AWS, our cluster is going to be where we're going to be running and creating our instances. So the command for that is going to be saying, for this container, create a cluster. And that cluster is going to be called Work From Home Ninja, WFH Ninja. We're going to tell it how many nodes that we actually want it. And we're just going to say 1. And we're going to say that it's going to be a small machine type. And this command actually is one of the few that we can actually run within the console. So you'll see here that the settings that we might have in this particular thing are actually similar to what we just set up in the console. And it'll even show us the command that we just put together in order to run it. So this will take a little bit of time for that to run and kind of set up the cluster for us. But while it's going, we can talk a little bit about how we actually got to manage that cluster. So we saw we had a bunch of screens within AWS to do those kind of things. But within Google, we actually need to use Kubernetes. And Kubernetes is essentially what you're going to be using to manage that cluster. And we can only be really doing that from the CLI. Kubernetes is an open source project that Google's released. And the commands that we do are going to be conceptually similar to what we just did in AWS. So now that the cluster is actually created, we can actually list the instances. So we see our one instance that's a small. And after we have that instance going, we're going to run Kubernetes, which is a kube control command. And we're going to tell it, as we get this going, to run the work from home. And similar to what we did locally with Docker, we're going to tell it the image, and we're going to go we're going to reference the one that's in Docker Hub, which is jeff/workfromhome-ninja, and we're going to tell it on port 5000. So the container is actually set up, and it's going from there. And then we have to do two more things that are going to allow us to connect and access it. The first thing is we're going to expose it to the regular internet, because by default, it puts it into the internal Google networking. And so we're going to create an external load balancer. And that's going to allocate a public IP address to it. And it takes a little bit of time for Google to get that IP address going. We can run this command on Kubernetes just to show us the instance and its IP addresses. And once it's done creating the load balancer with the public IP address, we'll actually see it under the IPs that are there. It's not there yet, but we can just check back on the console and kind of like transpose together what we're doing on the command line with what's on the console. And it's not ready yet, so let's just check to see what's going on here. Still not ready yet. But we did a refresh on this side. We can actually see the Work from Home Ninja cluster, which we created from our command line with all this kind of settings that are over here. OK, so now we ran the same command. We have the public IP address now. So the last thing that we need to do is we need to open it up within not Kubernetes in the cluster with 5000, but open up the port 5000 within our Google account to have against its firewall. So we're just going to create a rule for it that will allow 5000. And then we're going to say, just give it a tag because we want to be able to see all of our firewall rules within the Google Cloud, which is separate from the container engine part that we're doing everything. So after that, we can, so this was our local one. This was Amazon. And so this is Google. So this is that same container that we created locally, ran on AWS, now running in Google. So what did we learn about Google? Google is heavily CLI driven with Kubernetes. It's actually probably the most refined and the most plug and play of taking a container you have publicly available, putting it on the Docker Hub, and just getting it up and running within a container really quickly. You saw essentially we had to wait a little bit, but we had within 5 commands a container running on Google's Cloud Engine. Documentation was actually very good for it. You get a lot of Google's infrastructure, and like I don't know how many of you guys are working in different environments, but I know that AWS is probably the most popular. But Google has a lot of equivalent services that you can kind of run with, like RDS. It has the load balancing. And in the end, Google actually does this really, really well because they've been using containers internally for like over a decade. And now that they're getting popular within the public, they're applying all the stuff that they've learned internally to the open source like alternatives like Docker. And finally, with the next service that we're going to go over is Azure. So this was actually a little bit of a learning experience for me. This is the first time I actually did anything in Azure. And the first thing that we need to do is create an instance. You'll notice it's actually really nice looking console. It's very Metro-y or whatever they call this UI now. I'm not really sure. The one context we're going to let this show you, this kind of things of what I needed to do to actually bring in instances, is actually that Azure, though it has great container support, doesn't have a similar container service like we just saw with Google or Amazon. We actually need to bring an instance up and run a Docker host on it on its own. So what that means is that like everywhere I was within the console of Google or AWS, just giving it the parameters that I did locally with port 5000 and jeff/work-from-home-ninja, I actually can't do that directly within Azure. I need to bring up an instance, and I need to install the Docker extension onto it. And once the Docker extension is on it, it will actually expose Docker host over the internet to your computer. And then I'd be running the commands like I just did in the very beginning to run it locally against the instances that are running in the Azure cloud. So this is just like a little quick intro to how, like running through the Azure platform here. And you'll see that we have a server set up and created with the basic settings. And it's going into here and then going to the extensions that will allow us to install Docker. Once it's installed, then we're going to be able to do those kind of things. And so it's kind of not too much here. And while we were doing it, Chris, can you talk us a little bit about how we can get Docker on Azure?
Yeah, so one of the things we found is that it's definitely not ready out of the box. It gives you like a pretty vanilla VM that you can do anything you want with, which is great. But their extension actually installs a not terribly current version of Docker. It was a few revisions behind. So we actually ended up just completely uninstalling everything and reinstalling Docker from the main repository. So it's great for running like a regular virtual machine, but it's definitely not out of the box. So beyond all of these things, we were thinking about like other ways to make this more interesting and more and great, but so Docker Machine is actually a new package that Docker put out in their Docker Toolbox, which I think came out last week. And it actually helps automate some of this process. So it basically calls the APIs of the 3 providers that we just showed and kind of like does all this behind the scenes work for you. So there's hope for Azure yet to come to be a little more plug and play like the other guys. And it's also really interesting to think about automating Docker builds and Docker deploys with continuous integration. We're big Jenkins fans, and doing all these steps that Jeff was doing when he was demoing about like Docker build and tagging and pushing can all be done with like a continuous integration service. So that's it. That's all we've got. We have all the links to all the repositories that we've used. Feel free to tweet us or friend us on anything and send us an email. And if you guys enjoyed this talk, we have a podcast called Control C where we talk about other tech things. And yeah, so any questions? We have time for questions. Sure.
The first 2 examples you were looking at, those are managed Docker services where you're not doing things like upgrading Docker yourself, just running a container.
Correct. Yeah. So the question was, were they like managed Docker services? And yeah, absolutely. Amazon and Google are kind of like managing the version of Docker under this behind the scenes, as opposed to Azure, which is a little bit more like on your own.
And just because you can actually, if you wanted to start up an AWS instance or a Google VM, you could actually probably do something similar where you can run Docker on the VM itself and then manage it all yourself. But as things mature with Docker and containers in general, I think there's a big future of having that managed because like you can see the power of like taking essentially a Dockerfile that you create that container and push it to anywhere that can run containers.
It's also worth noting that Azure had top-tier support for CoreOS, which is kind of like another operating system based on Linux that is built around Docker from the ground up. So that's probably right now as close as you can get to a managed service on Azure. Sure.
So Docker essentially gives us cloud provider independence of the schema. So I could take my Dockerfile, run it on Amazon or Google, whichever one is cheaper, right?
Yeah, exactly. So it's its own specification, which in itself is kind of an interesting lock-in. There's another container service called Rocket by the CoreOS team that's competing against Docker for like building and distributing containers. But exactly, yeah, any service that supports Docker will be able to take any of your files that you create. So
let's say I have an application that's compute intensive, that I'm building something and I want to save time, save money in terms of doing it on AWS. I could essentially build a container entirely on my laptop, and then when I'm ready, I just deploy it and have it run there.
exactly. Yeah, so you don't even have to worry about spinning up a development server because your laptop is completely capable of doing it. Mm-hmm. Sure.
In your initial example of the Dockerfile, with your running Postgres in the same container as the Flask,
Yeah.
can you speak briefly about the trade-offs of that versus like 2 containers, one with the app, one with Postgres?
It's great for a demo and getting one thing up, but it's an exercise for the reader to actually spit those up because you're right in that generally speaking you shouldn't be doing that, but like for a small thing that you might be developing, it's a lot easier to kind of say like have that as more traditional. But you're right that there should be many containers if you're going to be expanding this out and doing many things, or even using like service that might be on one of these clouds like RDS or Google's SQL.
It's also worth noting that persistent data inside containers is a kind of a tricky thing right now. We've experimented a lot with like things like Redis, like using caches inside of containers, and it works beautifully. But Postgres, yeah, for the sake of the demo, we went all in one. But Docker has great support for linking containers together, so that the traffic doesn't actually go over the public network. It kind of stays within like the host with clever IP tables rules and things. Sure, yeah. So Docker's so hot right now, so are microservices, right? So the idea of kind of having these really small, manageable containers that only do one thing and do it well, and separation of concerns, and also it lets you kind of like build out a container that if it were to go down, or like the availability of it, it won't take down the entire system, just a part of it. So yeah. So the question was if we can speak a little bit to integrating the container services with kind of like the managed database services on the cloud. I have not personally worked with it too much. I don't know.
I think that actually comes down to configuration. So you saw really briefly that in the Dockerfile, we exposed just with an environment variable what the connection string is to the database. I could just as easily expose that with a variable like on startup of the container with a connection string to an RDS or connection string to Google's SQL. I think that we're out of time now. Thank you guys very much.